All right, welcome back. If you've been following along, you'll know that we're ready to do some tests on the computer to see if all the functions are working. We started by checking the power supply, and we had to replace a couple capacitors. We found some bad RAM on the onboard RAM. Replace that. We found the keyboard was completely dead. Not one single key worked. After a bunch of trial and error, we got it working, and it's still working. Everything seems to be working 100%. So far so good. I'm still not happy with the foam choice that I used, so I'm gonna keep my eye out for a different foam, and eventually probably change it out to get a little bit. It's very stiff. There's only about an eighth of travel on the key, but all the keys are working. So let's turn it on. And we're up and running. So this is one of the first all-in-one computers. So basically you get it. It has the built-in keyboard. You plug it into a video monitor. And it has a ROM monitor, which is a small operating system. It has a few rudimentary commands. You can do some things. You could write a small program into the memory, you can run it, you can look at the memory, you can modify the memory, you can control the ports. There's a serial port, a parallel port, and there's a cassette port, and you can work those with the small monitor program. This also could be used as a terminal for, say, like an Altair 8800 or a computer that needed to have a keyboard added to it. So it's a serial terminal also. It has a mode in the little monitor for becoming a serial terminal. So we'll check that, see if the serial port's working. We'll check a few of the commands and see if the machine's basically generally working. So the way it came with only 1K of RAM on board, which is not a whole lot to do much. The memory map is 0 to BFFF, can be for user memory. Then from C000 to C7FFF is the ROM monitor, so that's the operating system. And then from C800 to CBFF is your 1K of memory, user memory. And then from CC00 to CFFFF is your video memory. And then from D up to FFFFF is more user memory. So it's kind of, they put the operating system and the memory right in the middle. So realistically, the user memory is from 48K, from 0 to BFFF. At the time, it's probably pretty good for most things that you needed to do. There are ways to use the memory above, but some of the cards, like for example the floppy controller card, it uses E800 is the memory address. And I'm sure some of the other S100 cards, I'm not really familiar with the S100 systems. I'm learning now. Maybe use some of the other memory, or you could address different cards to different parts of the memory. So anyway, let's try a few commands and see if we can get this thing to do anything. So I have the manual up. The first command is execute, EXEC, but we really don't have anything in there other than the raw monitor, which is already running. So if you say you put a program into the user memory, you could execute it. So you'd go execute EX and then the address of where the program started. Another command is enter. So an enter command, which is EN, we need uppercase on. EN, and you pick the memory where you want to put it. And so we only have memory at C800. Enter. Now it gives a little prompt. Now you enter your data. So say you're going to make a program. We'll just put it in FF, 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 FF. And then enter. So theoretically what it did is it put FF in those first 4 memory spots. So we can look at it by using the dump command, which is du C800, and we'll look at C810. And there we have it. So what that tells me is the memory is working, the monitor is working. So our enter command or dump command. There's some other commands, but there's one that we can try. It's terminal command. What it does is it puts this into terminal mode. And what that will tell us is if it's working, is that the serial port's working. So I've got it hooked up to my other computer, and I got TerraTerm running on it. So what the command is term, of course, like terminal. Enter. So now, when I type on the keyboard, the SOL keyboard, it should come up on my terminal, and it is. Now if I type on my regular computer, it should send it back to the SOL, and it should come up on the screen. And there it is. So that tells us that the serial port is working. And there's some other commands. I don't have a cassette deck hooked up into it right now, so we can't test that, but maybe down the road we'll give that a try. And you can set a few other things, but I'll put a link to the manual if you want to read through it and see the different commands. So what we'll try to do now is we'll try to add in some more memory. So the board, the system when I got it came with these memory boards. Each one of these memory boards is 8K, and you can select where you put them in the address space with these switches. So it came with 2 of these things for a total of 16K. And these things are really power hungry. There's a lot of chips. You know, you need, these are all 1-bit chips, so you need 8 of them. And you got 8 rows, so 1, 2, 3, 4, 5, 6, 7, 8. So each one of these is 1K each row, so you have 1 bit. You need 8 bits to make the byte, and so this is 1K. These are 1 bit by 1K chips. So you need 8 of them to have 8 bits to be 1K, so you got 8K. So you could select these, so you could get up, the thing would have 16K. But we want to run CPM, get a disk drive going with this thing. So we need a little bit more RAM than that. That's all I have. But I did build this RAM board for my Altair for some other reasons we'll talk about in a different video. But this board has 64K of SRAM. It also has a 64K ROM and a couple serial ports. We'll just ignore the serial ports for now, and we'll concentrate on using these. So what I've done is I've addressed this board to use 48K of RAM, and then I found a program that enables you, that works with the disk controller that came with this, which is a North Star controller, single density, hard sectored floppies, which I have some, so we're gonna see if we can get this going down the road in a later video. So what I've done is I've programmed this thing to use the first 48K of RAM, and there's a program that writes disks. And what it does is you put a disk image in, say, your PC, and it'll transfer it through the serial port and write a disk image. So you can load this program through the serial port into RAM and then run it. But what I've done is I've actually put the program in the ROM up in address space of D. There's one that writes a disk. It's called PC to floppy. And then there's also one that's floppy to PC. So if you have a floppy that has information on it, you can back it up and dump it down to your PC. So I've put those two programs on this ROM. So theoretically, when we put this thing in there, if all the address stuff is working and this card is working, this card wasn't designed for this specifically, it was designed for my Altair. But the S100 bus is a fairly standard thing. So hopefully it's just going to work. So we'll do some tests. There's a couple things that we can try to get it done. And if that's working, then we'll have enough memory to run CPM. We'll have the software to make a disk. Then all we have to do is try to get a disk controller working in a disk drive. So let's plop this thing in here. Oh, well, let's do it up here. So this is a neat thing I like about this. It has this bus board on the top. So this is awesome for troubleshooting. Like, you can just like work right on it. You can get your probes on there instead of like having to dig down into there. So any board that you're working on, you just stick it on the top here and away you go. So let's fire this up. Okay, it's still running. Okay. Turn the case. So how do we want to do this? I guess we'll start by, we'll just try to write something right into here. So we'll enter. We'll enter it right at 0000 at the base. And let's put in FF, AA, BB, CC, 55, and then we'll backspace. Enter it. Okay, now let's dump that. Dump 000 0. And we'll go to 0010. And FF, AA, BB, CC, 55. Perfect. So at least we know that memory 0 and the first few is working. So what we can do is we can incorporate some of the commands from the ROM monitor. And this program to make the floppy, it was compiled to run at address 100. So instead of recompiling the program to work at up in D and do some changes, what I did is I wrote a little bit of code right at the beginning. And what it does is it takes the program from the ROM and it puts it down starting at address 100 and fills the memory up there. So what we'll do, and then it executes it at 100. So this would be a good test to see if our ROM is working and to see if our RAM is working. So what we do is we want to execute the program, and the program is at D000, and that's where I put it in the ROM. And if we hit this, something should happen. And there we go. We have the program running. There's no floppy controller, so nothing's going to happen. I'll try pressing one of the buttons, one, and see what happens. It's probably just going to error out. Drive stuck on track 0. Well, there is no drive and there is no floppy controller. So we'll just hit X,
which is a good sign. That means that the low memory is working. And it's exiting.
Okay. So it took the program from the ROM, put it down in memory. So if we execute from 100 now, EX 100, the program should still run.
Because it should still be in memory. And there it is.
We'll exit again. Now, the second program that I put in D800 is a floppy to PC. And that does the same thing. I wrote a little program and put a little piece of code in front of it that drops it down, loads it from the ROM down into memory at 100. So if we execute at D800,
now we have the other program running, floppy to PC.
so if we X out of there, and then we execute at 100,
It should be running.
yes it is. So what that tells me is our memory card is working. It's selecting the ROM, and the RAM is working. The monitor is working. The serial port is working. Pretty much everything is going. There's really not a lot more we can check out. Like I said, I don't have a cassette deck hooked up, and I wouldn't have any cassettes. We'd have to put a program in and then save it to the cassette, and then try to read it back in. But because the serial port is working, I believe probably the cassette port is working, and probably the parallel port is working. We could do some tests on that in the future. So what we're going to do now is I think we'll put this board into the system, and we'll load up, start trying to do some work on the floppy, and see if we can actually get a floppy to boot, floppy to run. So all in all, you know, I've had computers reopen up and there's a lot of problems. So for the age of this thing, we really didn't have a lot of problems other than, you know, power supply a little bit, one RAM chip. Of course, the keyboard, which is notorious for all these things, was completely dead. So it's a pretty robust machine. Pretty happy with that. So our next step is going to be to work on the floppy controller and see if that's working. So I'm going to have to gather up a floppy disk, somehow see if we can get a cable, gather up some equipment. Alright, well, thanks for watching. It's not as much troubleshooting as I thought we'd have to do. It's pretty much going. So let's get the floppies up and running.
Thank you. We'll talk to you soon.